All right, I believe we are online right now. Actually, Google says I'm live right now. So, well, good Saturday to everybody, and welcome to our second webinar. To our webinar on Pytorch and Udacity's GPU Workspace. This is a webinar targeted towards the second project. So we'll be talking about Pytorch. I'll be showing projects that I did to solve something on another problem using Pytorch. So you guys get a little bit of code. I'm gonna send the code to your classroom, so you guys can toy with it as much as you want. So let me adjust my machine a little bit. Okay, perfect. So if we get going, I'll begin by showing you guys what Pytorch is. So this is our schedule. First, we'll show what Pytorch is and how to use it. You'll get an overview of a personal project of mine. They use Pytorch, so that's when you get the code. You get to see the code, how much you coded. I'm gonna send the file and the details to you, so you can play with it as much as you would like. I hope you do play with it with the adjusting adjusting the layers, the size of the layers. See how it differs. What else? I'm using a technique to validate, which is called k-fold. Something else that is on the notebook. I hope you guys take a look at that. What else? The loss function that I'm using, I hope you guys can change the loss function so you can experiment with different loss functions. So yes. So then what we do a brief overview on the second project. I'll just go through the second project real quick, just so I can see if there's something, so I can show everything to you. And then I'll be open to questions. Of course, I'll also be open to questions after this live webinar. And you can pretty much give me the questions whenever you want. I'll be happy to reply to you whenever you want, as I'm always doing. So yes, any question, once again, would be welcome. There's no such a thing as a stupid question, because, well, there's no such a thing as a stupid question. That's just it. Maybe these basic questions you think it may be too basic, but actually maybe something that is quite at the bottom of the learning necessity and will be necessary to help you and maybe even your colleagues to understand something that is fundamental to the topic. So if we get going, let's take a look at the Pytorch, and I am starting sharing my screen with you guys right now. So sharing, and hopefully you guys can now see my screen. Okay. And let's start by what is Pytorch. So let's go to the Pytorch official website. Well, this is Pytorch. Pytorch is actually a collection of tools and libraries, so it would be a framework that allow you to deploy deep learning models using very pre-advanced techniques like GPU acceleration, which is using the GPU, geographic cards, to optimize to better train your neural network faster. As you guys hopefully, I hope you guys know, GPU is much faster when training a neural network, because GPU is a hardware that was specifically designed to work with matrix multiplications. That's what video games basically are. They are the graphics are matrix multiplication, and you have these amazing hardwares called GPUs that are designed to do that pretty fast. I mean, they have been on the market for maybe over a decade, much longer than a decade. As long as you can remember NVIDIA, they have been improving the hardware. And a few years back, a group of engineers and scientists found that it is a very good way to optimize to optimize neural nets, because basically neural nets are also multiplication. They would take advantage of the advances done for gaming, and that's why you have. But that would require code. So what you have with Pytorch is a simple way of doing that. People have implemented the code. People at Facebook, actually. This is a framework owned by Facebook, actually, but it's open source, so you can do whatever you want with it. And basically, you have access to these amazing tools, these amazing codes done by Facebook, by the AI research at Facebook. So it has everything you need, so you don't have to write a lot of or be low-level code that would always be the same. There's no need for you to implement by hand. So that's what Pytorch does to you, because you can implement everything in, let's say, any language you want. But what Pytorch provides to you is an implementation, so you can just focus on building the network, like defining loss functions. I mean, they have the loss functions, so you just choose one. What else? Define the layers, the size of the layers to really solve your problem, not focus on low-level code. So you have this tool, which is called Pytorch. And yeah, let's get started. You can play locally. By locally, I mean you have to download this code. So you run this command, which is by Anaconda. Anaconda will install Pytorch to you. Note here where it say CUDA. CUDA is the NVIDIA's unified architecture to performing the calculations on the graphic cards. So if you have a NVIDIA graphic card with CUDA at least 8.0, 9.102, 10.0 will do also. Maybe you don't even have so pretty much you don't have. I actually don't have one because I have a Mac, running on a Mac. But what the GPU does is allows you to train deep learning models when you have loads and loads of data, much faster than what you would get with CPU. No matter how fast your CPU is, it is always gonna be slower than let's say a $400 graphic cards for doing the same task when it comes to matrix multiplication. So you already have the implementation with Pytorch. So this is what Pytorch is. It allows you to deploy, to create deep learning models, and even deploy them. I mean, you have it's basically the Facebook version of let's say TensorFlow, Google's TensorFlow. So Google has TensorFlow, Facebook has Pytorch. Right now, TensorFlow is on the front because it started first, but PyTorch is is a more modern approach. So I believe it will. I believe the whole community thinks already realize that it will eventually surpass TensorFlow. At least we hope so, because it is a more modern approach, and the way you write code is much better. It's much more Pythonic way. So this is what PyTorch is. You install it through your Anaconda, and you can import later, as I'm sure you guys will see on the second project. So now that we've done that, let's get to our let's go ahead and let's take a look at what I mean by a deep learning framework. So please allow me to open my notebook, see where I'm at. I'm going to desktop. I'm going to close that. I'm going to your cohort. So I'm going to cars. This is the project I have worked on using PyTorch. It is a basic project. I was doing this to test a few algorithms for classification using unbalanced data sets. So it's pretty much an academic project, but I'm not even doing deep learning per se. I'm just instantiating a 3-layer network. I'd like to show this to you. Give me a second. This is what I'm talking about. This is a normal neural network. It just only has 3 layers. When we say deep learning, we actually mean that we're gonna put more layers inside the neural net. So here we have 2 hidden layers, but you can have 400 hidden layers. That depends on the problem, and you can easily find online. And actually, Pytorch has some of these neural nets saved, because they were famous neural nets that were once used to found to be helpful to solving certain kind of problems. So you have these neural nets pre-built inside Pytorch. You can pretty much load in. Some famous neural nets, they have maybe 400 hidden layers. In this example, you see this dot, dot, dot. It means that you can have pretty much a lot of layers here, 400 to 1,000. But this is basically the difference between standard neural network, has 3 layers, and deep learning model, which has more than 2 layers, more than 3 layers. You see 1, 2, 3. You have let's say 4 layers in this example, but you can have 400, or differences between is in the amount of hidden layers that you want to deploy. But you can have this many, and this is what deep learning is. This is deep learning. This is deep learning. This is not deep learning, but this is a neural net, and it's still useful to solving lots of problems. Actually, I'll say that in 90%, 95% of your problems, you don't need a deep learning model. You're pretty much fine with a normal neural network. But this is the difference. I want to point out why what we mean when we say deep learning and when we say neural nets. This is a neural net. This is also a neural net, but as it has more hidden layers than a single hidden layer, this one is also a deep learning model. So that's pretty much it. There's not much else about the difference between deep learning and neural nets. But basically, deep learning models are neural nets that have more hidden layers than a single hidden layer, which is found on your standard network. So let me proceed and open my notebook. Here I have this is a project what I use for deep learning. A very big one, but still, as I said, I was doing some research on solving the problems that had an unbalanced neural network. So the first slide, in the very first line, what I'm doing, importing Pytorch, and this is the Pytorch. It is called Pytorch when you import it from Python. Importing neural nets. I'm gonna use pandas to load the data set, as you pretty much sure you guys are familiar from the first project. I'm using NumPy, matplotlib for plotting. This is a personal library of mine. I'm also gonna include when I send you guys the code. Pretty much just plots the hop curve and the AUC, because I was evaluating each model using the AUC. So let's go ahead and run this code. Done. I'm loading. I have loaded the file, which I call it nose mode. No, I'm sorry. This is the file I'm gonna write the results to, and I'm gonna write all this metrics, AUC, ACC. I'm loading a bunch of evaluation metrics here because I wanna evaluate the model against all these metrics. And this is the files where I'm gonna write results. I mean, it's the same file when you run on your computer, you're gonna get results. So here I'm loading the dataset, which I call processed because I did some data cleaning. I processed the file. So let's go ahead and I actually don't even need this code, but this line because I have already loaded my grader here. But I included it anyway because I believe I was working late, so I didn't see that it had already loaded the required library. So I'm gonna end this code. This entire code has already been loaded, so I'm not even gonna bother loading it. Just gonna look at the data. You can see that it has loaded. I mean, you have this many variables, and this is the variable that I want to predict. So I'll go ahead and separate everything. The target, which would be class, and the rest of the features, the is gonna be everything but the class. So I'm gonna drop class. So here I'm gonna see how many variables do I have. I'm gonna actually put in this variable. So let's see. So from here to here, the variables that I'm gonna use predict, they are pretty much 21. 21 that will be used to predict this one variable. So here's what I was talking about. I was talking about k-fold validation, which just means that I'm gonna separate the data set into 10 pieces. I have chosen 10, but you can pretty much choose well, any number that has some that has at least one sample for each division. But I'm gonna split the data into 10 blocks. I'm gonna shuffle. I'm not gonna shuffle these blocks, but I have 10 blocks, which I'm gonna do. I'm gonna make a copy of these 10 blocks, and each time, so I can run my neural nets 10 times. Each time I'm gonna leave one of these blocks out, a different block out, and I'm gonna use the rest of them to train the network. And just in this way, I can see how good my neural net will generalize from a random when I start using it to predict something that I don't have labels on so when I'm gonna actually use it. So I'm putting everything inside these vectors. This is a vector. So let me do that, which is done. Let's see when I have. See, here I have. So I'm testing again to see if we have. So I have on my X string, I have my X string 0, but I have, like I said, I have 10 of those from 0 to 9. I have 1,554 samples. Each one has 21. Each one has 21 variables. And pretty much this is the input layer. And here I'm using Pytorch, already starting Pytorch to define my neural network. So what I'm gonna do is I'm gonna start by the first layer. This is how you do it. You pass the first layer to the you put the input layer size, the hidden layer size, and from the hidden layer size to the output size, because I'm only using one hidden layer. If I wanted to use another hidden layer, what I'll have to do is something like this. I'm not going to use EC, and here I will be defining another activation function for this second hidden layer, but I'm not going to use 2 hidden layers. I'm going to use a single hidden layer to solve this problem. I was actually doing the research on neural network, not without using deep learning. Here I'm instantiating this class, and I'm already started this class. This class I'm gonna instantiate with name model, which is an input layer. As you remember, the input layer is 21. So you always in this first number you always put the number of variables that each sample has. To the output, to the hidden layer size, I'm gonna use 18. You can pretty much use even 100, let's say. But this one is chosen by you. But as I say, a good rule of thumb is between between the output layer size, which is, in this case is 1, to the input layer size, which in this case is 21. So I have chosen 18 and it worked very fine. And I'm instantiating it like that. And here's the training. Because my variables are not they are not in a tensor. So pretty much what I'm doing here is I'm taking the first training data set, which is setting here as ng. Here I'm going from 0 to 9. I'm gonna try on the first one first. So I'm gonna take the training set 0. The target set also 0, of course. This was the separation I did on the k-fold. The first k-fold I did. And here I'm just using some code to tell me everything in a tensor, and I'm gonna use this loss function. I mean, if you guys are following the material, is going to be pretty simple to you. But him, I'm using the minimum square error, and I hope you guys change it. Try with while optimizing to the MSCI loss, and change the optimization loss, just to see how your model behaves, how your matrix, how your metrics after changing. And I'm gonna optimize by hope you guys also change this to see your test for your own trials, which is the number of epochs. Basically, I'm gonna run this training through all the data 150 times, but you guys can pretty much choose as much as you want, from basically 1 to as many as you have time and patience to let your model optimize. I'm using instantiate this loss vector, so I'm gonna start the loss for each iteration, so I can pretty much. Actually, I'm gonna change this. I'm gonna look at 500 iterations. It's gonna take a while. I hope you guys are ready to wait for some time, but it's not gonna be too much because, as I said, I don't have that many samples. It's not such a complicated model. I don't have too much data, that so it wouldn't be that long. But if I had a lots of data, lots, if I was classifying images, for example. Each image has several numbers on them, so I would pretty much could take me quite some time if I decide to run this, because I'm not using a GPU. I'm gonna use the AutoGrad. Basically, this is on your material. if you guys have any problem understanding this, but this is just calculates the 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 vector, your gradient vector, to optimize your model, to adjust the matrix weight, the matrix of weights. And here I'm doing the training. I'm doing this training on these tensors. As I have, this is pretty much these files, these converted to tensors. You have to use tensors when you're dealing with Pytorch. And here's pretty much standard code. So I can write the files, what my model, the evaluation metrics, and I can plot my evaluation metric. And yes, here I have a previous result that I tested. I mean, it is a good ROC curve, 0.9. It is a useful ROC curve, but a perfect ROC curve would be around here. So here's you can see I have some ground to improve on this K-fold. I don't remember which K-fold it was, but this one I'm trying at 0, and I probably gonna get a different result. So let's run the training. And let's wait for 500 epochs to complete. It's gonna take some time. Please sit tight and wait. As I said, training a model takes some time. If I had more layers, it would take me even more time. It could take me the whole day, depending on the amount of layers. It could take even more, depending on how many layers I would instantiate. But in this case, I went with a single hidden layer. So I'm already at 130, and I'll be 500 no time soon. So please sit tight and wait a little. We're gonna see the result of this training, and I'm also gonna see the result of the losses. I mean, when your model is converging, of course, the loss, the error is gonna decrease along each iteration. So here I had an example when I did 150. You can see has errors, but as you can see, the model is converging because I see the error reducing at each iteration. At each epoch, I have a smaller error, and when I hit 150, I have this quite small error. Maybe I would have an even better result if I had that running a little bit further and a little more of optimization. But I stopped the model right there. We're gonna see again how the losses were when it finishes for 500 epochs. 300 already. So I believe you guys won't do this. You won't be opening files. You're gonna have a different model of loading for your second project, which is much better. This is because I wanted to use this file of mine, this data of mine, to solve this problem. So I had to do this. I had to convert into tensors. For you guys, when you load the data from Pytorch, it will already be tensors. So don't stress about this code. You only have to think about this. This is the training in itself. This part. What it does is it trades through all of your epochs, and here you're gonna pass each and every single item to the forward, pass forward, uh, compute the loss, and move the loss backward. And here I'm setting the error, so I can store this error. I'm accumulating zero, and after all the samples, I'm dividing and storing it in this vector, so I can see how my model is performing. If it's actually converging. You can see that this won't converge because it actually reduced, the error got smaller and smaller. Maybe if the error was jumping, it would mean there's not converging, but this one was, and I hope this one does the same thing too. We're almost done, almost finishing training. As you can see, I mean, with this little data and such only one hidden layer with such so many views, only handful of neurons on the hidden layer, it's not very difficult to optimize a model. So even my notebook, my MacBook can do this. But if it was a serious, more serious problem, probably, and I got the perfect Hawk curve. You can see the Hawk curve because it's here and here. And my AUC is actually 1, so the perfect separation, at least on this scaffold, to actually test for generalization. I'll have to run this again on the first, second, the third again. Then I would run on the number 5 and do all the training and testing. Run the 6, on the 7, on the 9. Not just on the 9 because I divided in 9, but actually can divide in pretty much as many as you want. As I said, you can divide in 100, let's say, and try 100 trainings for and 100 metrics, measuring the optimization of a model 100 times. It would take quite a while, but it would be give you a much better estimate on optimization. Let's look at your error. As you can see here, I actually got a pretty solid result. I mean, if you compare to the previous one, this one actually, as you can see, I'm starting to converge. I'm starting to not get any reduction on the error itself, which means that my model is reaching the maximum it can do. And that's pretty much it. I'll send you guys this code. It's gonna plot the Hawk curve. And it's gonna, you can look at this. I'm sorry, I'm gonna change this. How do I do this? Now I can give you guys this. And that's pretty much it. This is a project using Pytorch. I hope you guys play with this toy. I mean, this part's not necessary for you. I mean, just something I did so you guys can actually play with basically 10 testing, 10 different sets of testing and grading and evaluating sets of data. So you can pretty much just run this code, and then you get here and you can run on the 0 index, see how your model perform, run on your 1 index, once again see how your model perform. I'm gonna write like this. So you guys can play with this too. I hope you guys play with this number of hidden layers, see how the model performs with different hidden layer size. I mean, you can pretty much put 100 here and see if it gets better or if it gets worse. Okay, so let me close this notebook. And if I go to the folder where I was, sorry, this is not. You can see the broad curves that is saved in save this file, which is the CSV file with some evaluation metrics. Just save this evaluation metrics for me. This is the confusion matrix, and this is the accuracy, and this is the AUC. Hope you guys play with this code. So I'm gonna zip this code and send to you. I can pretty much kill my notebook right now. And let's go to the next topic, which is Udacity's GPU. As I said before, you're gonna be using a GPU would be pretty awesome to have when you actually treating images, and you're gonna have access to a GPU workspace, which is a computer equipped with a GPU using Udacity GPU. Here you can see it's asking me to activate the GPU mode. I'm not gonna activate it right now. You'll see why in a while. I'm gonna, as you can see, you have a limited time with using GPUs. This is gonna be counting only when you enable the workspace. Just click here. It's gonna change to everything to an workspace with GPU. So you can use your GPU to optimize the model, which is gonna be good for training. But I'm not gonna enable it right now. We're supposed to load it. Yeah. Pretty much this is the first project. So you're gonna be using. I recommend you to do all the code, and when you are ready to start training, just then you enable the training. Do the training. It's enable. You have some explanation on how you can. This is the second project. I cannot show you guys much because unfortunately I have done this project, so I have a lot of code down there, so I cannot show you. I was hoping to do the brief review, but I cannot. Sorry, because otherwise I'll be showing codes that is actually done, code that you should actually implement this yourself. But basically, you're gonna do the same thing that you did on your lessons, which is loading the data. Pretty much everything. I mean, it's pretty much what you did. You maybe you even have the solutions. I believe Udacity provide the solution for when you did this using the MNIST. Basically, it's gonna do the MNIST using a different data set. This one's gonna be using, as I can show you, it's gonna be using flowers. So basically, you're gonna do the same thing that you did to the MNIST by using a different data set. So it's pretty much that. There's not much difficulty. What I want to pinpoint is that when you start training, you're gonna do so on the GPU. So this project you should not work on your local machine because I mean unless your local machine has a pretty decent NVIDIA GPU. Otherwise, you run it on it online because you're gonna be using Udacity resources that and they have a pretty good GPU, pretty good computer to run this model. I mean, if you have a slow computer, you're probably not going to be able to solve this problem on your computer. So that's why it doesn't provide the GPU environment for you. So pretty much what I recommend is doing everything that doesn't need the GPU with this disabled. And only when you are ready to start training, you click here, and you're gonna click here. Now my GPU is enabled and my time is running. I'm gonna have to disable it quite soon because I don't wanna waste my GPU time. So this is what you should do when you are ready to start the training. It's gonna only make a difference when you start the training. So what this does is send your Jupyter notebook to a much more stronger computer, and it has a cost for Udacity, so that's why you have a limited amount of time when training, and you should use only what you need. You should not waste your precious GPU time. I'm gonna disable mine right now because I don't wanna waste it. Now I'm going back to the same machines without GPU. I mean, GPUs actually also consume a lot of power, so that's why we have a limited amount of time. So, and they are expensive. Just out of curiosity, I'm gonna show you what a GPU is. This is a GPU, a very expensive GPU. This thing by itself can cost up to, I don't know, $2,000 maybe, because depending on if it is a scientific GPU. I mean, these are gaming GPUs, but you have some GPU much expensive than this one can get, and this one are already pretty expensive. This can cost for about $1,000, but in scientific GPU, which has more power and is used for these things, can cost you, I don't know, maybe $4,000. I mean, $1,000, that's a lot of money. That's why you doesn't provide this environment with a GPU for you, so you don't have to go ahead and spend money on a big computer just to so you can learn deep learning models. So you have this text. I hope you guys look, because this is how you. This is the introduction to the GPU support. How you open notebook and how you enable. Just click, as I told you. So just click enable, and you have this thing because the workspace it's connect you after 30 minutes of inactivity, and the training process may take longer than that. So you have to do this. You're just gonna put your training inside this command. You're gonna uh, copy and paste this line on your notebook, and inside this you're gonna instantiate your training, so your notebook will awake. So keep in mind that it is awake. So if you want to stop, you have to stop manually. You have to because we do this to prevent you from wasting your time, your precious GPU time. So we pretty much stop you if you're not doing nothing, maybe because you forgot to stop your 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 notebook from running. Maybe you just forgot and you are wasting time, so you're gonna stop it automatically. So that's why you need to put your code inside this, and that's pretty much it. So it's gonna be running and it's gonna be do the training, which is the long part. And once again, I like to reiterate that because only use the GPU when you are ready to start training. When you are loading the data, doing the code to load the data, you don't need the GPU power. So don't waste it. Please don't waste your time. It's your resources. Please don't waste your resources. Waste your resources. Just after when you are ready to start training, you enable the GPU and you do the training. So pretty much it. It concludes our today's webinar, and I once again thank you guys for coming and listening. And I would like to finish this webinar since we have no questions But once again, you can ask me questions through Slack anytime you like. I'll be pretty much happy to answer. So thank you very much. And I'll be sending you guys next, the codes next, just finish this transmission. And I hope you guys have a terrific weekend. And thank you very much. Have a good one.